Okay, so so we start problem set 9 by doing question 8.1 in the textbook. So the tutorial today is about game theory. Right, so question 8.1 giving you two player. So we have player 2 and player 1. Okay, so each of the player will be having a different strategy. So player 1 will be having a strategy A, B, and C. And player 2 will be having a strategy D, E, and F. Okay, so for each of the strategy, there will be a corresponding payoff for each of the player. Okay, right. So here you got 7, 6, 5, 8, 0, 0, 5, 8, 7, 6, 1, 1, 0, 0, 1, 1, and 4, 4. Okay, so we have all the payoff for all of the pair of strategies for both of the player 1 and 2. So question part A of the question asking you to find a pure strategy Nash equilibrium. Okay, so an easiest way to find the pure Nash equilibrium. So basically Nash equilibrium is the equilibrium at which both of the player are choosing their optimal strategy given the strategy chosen by the other player. Okay, so given the strategy chosen by player 2, player 1 will be choosing the best strategy that will give the player 1 the highest payoff, and given the strategy chosen by player 1, player 2 going to be choosing the best strategy that will be giving the player 2 a highest payoff, and then the equilibrium going to be the optimal or the best strategies for each of the player given the strategy chosen by the other player. Okay, so the easiest way to find the Nash equilibrium is to find the best strategy for each of the player and then see which is gonna be the best strategy for both of the players given the strategy chosen by the other one. Okay, so the first thing we do is we say we want to find the best strategy for player 2 given the strategy chosen by player 1. So we start with strategy A for player 1 first. So say if player 1 choosing A, what is the best strategy for player 2? So as you can see from here, by choosing D, player 2 will get 6, choosing E, player 2 will get 8, and choosing F, player 2 gets 0. Okay, so we say that strategy E is the best strategy for player 2, given that player 1 is choosing A. So I'll put 1 star in here to indicate strategy E, the optimal strategy for player 2 in this case. So we continue to do the same. So given that player 1 choosing B, what would be the best strategy for player 2? So as you can see, strategy D giving player 2 a payoff of 8, which is basically the highest payoff. And that's going to be the best strategy for player 2 given the strategy B chosen by player 1. So similar, if player 1 is choosing C, F going to be the best strategy for player 2. Okay, so we done choosing the best strategy for player 2 given the strategy chosen by player 1. We're gonna be doing for player 1 now. So we will choose the best strategy for player 1 given the strategy chosen by player 2. So if player 2 is choosing D, what is the best strategy for player 1? So as you can see, player 1 choosing A, it will get 7. If player 1 choosing B, he will get 5. And if he choosing C, he'll get 0. So basically, strategy A, the best strategy for player 1 in this case. So I'll put 1 star here. So if player 2 is choosing A, the best strategy for player 1 is choosing B because that gives him the highest payoff. And if player 2 is choosing F, the best strategy for player 1 is to choose C because that will give him the highest payoff. Okay, so I'll put another star here. So the Nash equilibrium is going to be the pair of strategies that including 2 stars. Okay, so it's only this one is having 2 star here. So basically it's a common optimal strategy for both of the players. So basically best strategy for player 1 given the strategy um, by player 2, and given this strategy by player 2, this is gonna be the strategy for player 1. Okay, so none of the player will have any incentive to deviate from this strategy, from this pair of the strategy. So basically this is the Nash equilibrium. Okay, so Nash equilibrium is where none of the player will have any incentive to deviate from that. So in this case, the pure Nash equilibrium is where player 1 choosing C and player 2 choosing F. So C and F is the Nash equilibrium. Okay, so remember when you write the Nash equilibrium, you will have to write out the strategy, not the payoff. Okay, so the strategy in this case is C and F, and that is the Nash equilibrium. Now B, find a mixed strategy Nash equilibrium in which each of the player randomizes over just the first 2 actions. Okay, so we only consider first 2 actions of each of the player. So basically A and B for player 1, D and E for player 2. Right. Okay, so player 2, player 1, we got D and E, and for player 1 is gonna be A and B. Okay, so that's 7, 6, 5, 8, 5, 8, and 7, 6. Okay, so we want to find a mixed strategy in which each of the player will be randomizing over 2 actions. Basically, they are choosing to play each of the action with a certain probability. Okay, so it's not a pure strategy anymore. It's a mixed strategy where each of the player are gonna be playing a mix of A and B, and in which each of the strategy will be played with a certain probability, and we want to find that probability. Okay, so we say that let alpha be the probability that the player 1 plays A, okay, so basically 1 minus alpha will be the probability that player 1 plays B. Okay, yep, so there will be 100% of like add them up, it will have to be add up to 1. Okay, so a certain probability that player 1 will be playing A, and the rest of that player 1 will be playing B. So we want to find the values of A and B. Also let beta be the probability that player 2 will be playing D. Therefore 1 minus beta is gonna be the probability that player 2 plays E. Okay, so I got alpha here, I got my 1 minus alpha here, I got beta here, I got 1 minus beta here. Okay, so that's the probability corresponding to each of the strategy for each of the player. Okay, so we just have to find the values of alpha and beta. So first of all, I'll say alpha alpha first. Okay, so in order to find alpha, we will just have to say so I'll find the probability that play by player 1. So in order to find alpha, you will just have to use okay, so if player 2 Okay, so we just say we do for player 1 first. Okay, so for player 1, so if player 1 is choosing A, okay, so if player 1 plays A, what player 1 will get? So the payoff to player 1 is, okay, so if he playing A, he will get 7 if player 2 is playing D. Okay, and he will get 5 if player 2 is playing E. So there will be a probability that there will be a probability beta where player 2 is playing D and player 1 will get 7 by playing A. Okay, so if player 1 choose to play A, he will get beta multiplied by 7 plus 1 minus beta multiplied by 5. Okay, just as I said, if player, so there will be a probability of beta that player 2 is playing D and player 1 will get 7 if he playing A, and he will get 5 if player 2 is playing E. So that will give you 5 minus 2 beta. Okay, so if player 1 choose B, he will get, so there will be a probability of beta where player 2 will be playing D and player 1 will get 5. So that beta multiplied by 5 plus there will be a probability of 1 minus beta that player 2 will be playing E and player 1 will get 7. So this will give you 7. So this will be plus and it will be minus 2 beta. Okay, so in order for player 1 to be indifferent between choosing A and B, and in order for him to be willing to randomize, otherwise he will be just choose whatever that give him a higher payoff, and that will become a pure strategy. Okay, so that's not mixed strategy anymore. So in order for player 1 to be choosing a mixed strategy, he will have to be indifferent between choosing A and B. Okay, so in order for player 1 to be indifferent between A and B, then the payoff he get by choosing A and the payoff he get by choosing B will have to be equal to each other, will have to be the same. Okay, so 5 plus 2 beta will have to be equal to 7 minus 2 beta. So so if I rearrange this thing, I will get 4 beta equal to 2, and therefore beta equal to a half. Okay, and therefore 1 minus beta will be equal to a half as well. So that basically means there will have to be a probability of half that player 2 is playing D and probability of half that player 2 is playing E, in order for player 1 to be indifferent between A and B. Okay, so that is for player 1. Now we do for player 2, so we do very similar thing. We try to find a payoff for player 2 by choosing the action D and E and make him indifferent in order to find the values of alpha. Okay, so we say player 2, so if player 2 is choosing D, he will get, so there will be alpha of the chance that player 1 is playing A, and he will get 6. So alpha multiplied by 6. There will be 1 minus alpha of the chance, so there will be a probability of 1 minus alpha that player 1 choosing B, and if player 2 is choosing D, he will get 8. Okay, so the payoff for player 2 by choosing D is gonna be 8 minus 6 alpha. Okay, so similar, if player 2 is choosing E, he will get so there will be alpha, there will be a probability of alpha player 1 choosing A. If player 2 is choosing E, he will get 8. So alpha, multiply by 8 plus 1 minus alpha. If player 1 choosing 1 minus alpha, probability that player 1 will be choosing B, and in that case player 2 will get 6 by choosing E. So the expected payoff for player 2, if he choosing E, is gonna be equal to 6 minus A alpha. Sorry. Right, so alright, so the first one will be A minus 2 alpha, and this one will be 6 plus 2 alpha. Okay. Right, so again, player 2 will be indifferent between choosing D and E in order for him to be willing to randomize only when the payoff he get by choosing D and E are equal to each other. Okay, so player 2 will be indifferent between D and E only when the payoff by choosing D is equal to the payoff by choosing E. And rearrange this thing, you will get 4 alpha equal to 2, and therefore alpha equal to a half, and therefore 1 minus alpha will be equal to a half. So that basically means half of the chance player 1 will be playing A, and half of the chance player 1 will be playing B. Okay, so the mixed strategy equilibrium, mixed strategy Nash equilibrium will be player 1 choosing A, and B with the probability of half and half. And for player 2, he will be choosing D and E with the probability of half and half as well. Okay, so those are the mixed strategy Nash equilibrium for both the player. Okay, so C, compute the player expected payoffs in each of the equilibria found in part A and B. Okay, so in part A, we found a pure Nash equilibrium. So basically, the expected payoff, which is the payoff that the player get by choosing the Nash equilibrium. Okay, so for part A, it is the Nash equilibrium C and F, and therefore the payoff for player 1 is 4, and payoff for player 2 E4 as well. Okay, so that's gonna be the last cell in the table where player 1 and 2 are choosing C and F, and each of them will get 4 as a payoff. Now for part B, we have the mixed strategy Nash equilibrium, where each of the player is playing the strategy with a probability of a half. Therefore, the expected payoff for player 1 is he will be playing A with half of the chance and playing B with half of the chance. So half of the chance he playing A and so expect. Okay, so half of the chance he's playing A, and in that there will be half of the chance player 2 will be playing D, and half of the chance player 2 will be playing E, and depending on the strategy chosen by playing 2, it will determine the payoff that player 1 can get. So half of the chance he will be playing A, and in that half of the chance he will get 7, because half of the chance player 2 will be playing D, he will get 7, and then half of the chance he will get 5, because half of the chance player 2 is playing E, and he will get 5. Okay, so basically this is the payoff if player 1 is playing A, and the half here, which is basically half of the chance he's playing A, and this is the payoff he get by playing A. Okay, half of the chance the player will be playing B, and the payoff corresponding to the strategy B will be half of the chance player 2 is playing D, and player 1 will get 5. Half of the chance player 2 will be playing E, and the player 1 will get 7. Okay, so this is the payoff player 1 will be able to get by playing B. So together I get half here. The payoff that player 1 can get by playing A is 6, plus half of the chance he playing B, and by playing B he will get 6 again. So basically he will get 6, an expected payoff. Okay, so that is how we find the expected payoff for each of the player in the mixed strategy in Nash equilibrium. Okay, so we do a very similar thing to find the expected payoff for player 2. So similar, player 2 will be playing D with a probability of half, and playing E with a probability of half. So half of the chance he will be playing D, and the payoff he gets by playing D E gonna be equal to so it depends on the strategy played by player 1, and that will determine the payoff that player 2 will be able to get. So half of the chance player 1 will be playing A, and player 2 will get 6 if he's playing D. Okay, and half of the chance player 1 will be playing B, and corresponding to that player 2 will get 8 if he playing D. Okay, so this is the payoff he get by playing D. Now half of the chance player 2 will be playing E, and the payoff he get by playing E will be half multiplied by 8. So basically half of the chance player 1 is playing A, and player 2 will get 8 by playing D, and half of the chance player 1 will be playing B, and player 2 will get 6 by playing E. Okay, so this is the payoff for player 2 if he is playing E, and therefore the expected payoff for player 2 will be half multiplied by 7 plus half multiplied by 7, and that will just give you 7 for the expected payoff for player 2. Okay, D, draw the extensive form of the game. Okay, so basically the game in the table is a simultaneous game where both the players are playing simultaneously. Now extensive form of the game basically means one of the players moving first and the other player gonna be moving second. That's basically the game tree that we have to draw, and another name is the extensive form of the game. So basically we assume that player 1 is playing first. Okay, so he will be choosing his action first, and then player 2 will be observing that action and then choosing the action accordingly. Okay, so player 1 can play A, player 1 can play B, and player 1 can play C. Okay, so he will be playing first and choosing either A or B or C. Now player 2, so for each of the case here, player 2 will be choosing the strategy for player 2. So here player 2 can choose to play D, E, or F, D, E, or F, oops, D, E, or F. Okay, and we just have to write the payoff for each of the actions here, for each of the pair of the actions here. So if player 1 is playing A, player 2 is playing D, the payoff will be 7 and 6. Player 1 playing A, player 2 playing E will be 5 and 8. That will be 0 and 0. Okay, so we continue to do that for the rest of the tree. Player 1 playing B, player 2 playing D, the payoff will be 5 and 8. That will be 6 and 7 and 6, and that will be 1 and 1. Player 1 playing C, player 2 playing D, the payoff will be 0 and 0. Payoff here will be 1 and 1, and the last one gonna be 4 and 4. Okay, so it's basically a different form of the game where the player are moving sequentially. In this case, player 1 is moving first and player 2 is moving second. Okay.